Hi everyone, welcome to lesson 4.0, solving quadratic equations by factoring. In the last unit, we developed skills in factoring polynomials, and factoring polynomials is considered to be the opposite of expanding polynomials. So let's fill that in. And polynomials by themselves are considered expressions. When they look something like ax squared plus bx plus c, that happens to be standard form. But obviously, while polynomials with an equal sign, they become equations. Which brings us to the idea of solving a polynomial, solving a quadratic. So ax squared plus bx plus c equals 0 is now our equation. So to solve quadratic equations, the function has to be equal to 0. So let's take a look at what that actually means. So x squared plus 3x minus 4 equals 0. Okay, this is an equation. It happens to be in standard form on the left, and it's equal to 0. So let's take a look at the graph of this function. So over here, let's take a look at some of the characteristics we have. If we identify some of the characteristics, we'll see we have an x-intercept here and an x-intercept here. And then we have a y-intercept right here. So our x-axis is here and our y-axis is there. So let's circle them just to highlight them. So what are the x and the y-intercepts? Well, in the y-intercept, it's -4. And that coincides to a polynomial, a quadratic in standard form. The constant term is your y-intercept. So that's why these two match. And then the x-intercepts, these are the points at which your graph crosses the x-axis. And from this graph, it looks like it is -4 and 1. So the solutions of a quadratic are the points at which your quadratic crosses the x-axis, or the point at which the y value of the function equals 0. So let's stay with the same quadratic and see if we can factor it. It's a simple trinomial. So we're thinking of two numbers that multiply to give you -4 and add to give you +3. And we've had lots of practice with this. So we could have a -1 and a +4. We could have a +1 and a -4. We could have -2 and a 2. And if we add these pairs together, this is the pair that seems to be the answer. So let's write our trinomial in factored form. And we have x minus 1 times x plus 4. So again, to find the solution of a quadratic, we set the y equal to 0. And when you set the y value equal to 0, you find the x-intercepts, or the solutions to the quadratic. This brings us to something called the zero product property. So if the product of two or more factors is 0, then at least one of those factors must be 0. So in mathematical terms, if a times b equals 0, then either a has to equal 0, or b has to equal 0, or they're both equal to 0. So let's solve these factored forms of the quadratics using the zero product property. So x minus 5 is one factor, and x plus 3 is the other factor. And by the zero product property, either the first factor, x minus 5, is equal to 0, or the second factor, x plus 3, is equal to 0. So when we solve those, we'll get x equals 5 or x equals negative 3. So we set the first factor equal to 0 and the solve for x. And then we set the second factor equal to 0 and we solve for x. So there's two solutions to this example. That means there's two x-intercepts for this parabola. Let's do that again, where we have one factor that is x minus 6 and a second factor that is x minus 2. And by the zero product property, we're going to take each of those factors and we're going to set them equal to 0. So we'll take the first factor, which is x minus 6, and set that equal to 0. And we'll solve for x. X here is going to be positive 6. And we'll take the second factor, which is x minus 2, and set that equal to 0. And the x value here, when we simplify, is 2. So the solutions to this quadratic is 6 and 2. And again, that is where the quadratic, the parabola, is going to cross the x-axis. Continuing on, we have another factor here, 2x minus 1, and this second factor, x minus 2. So we'll take the first factor, 2x minus 1, set that equal to 0. We'll solve this. 2x is equal to positive 1, and x here is equal to 1/2. And then we'll take the second factor, x minus 2, and set that equal to 0. And I simplify here, x equals 2. We'll continue with our next example. Two factors. We'll take the first factor, negative 3x plus 9. We'll set that equal to 0. Negative 3x is equal to negative 9. Divide through by negative 3, and we'll get x is equal to positive 3. Then we'll take x minus 8, which is the second factor, set that equal to 0, solve for x, and x will equal 8. So again, the zero product property allows us to take each factor separately and set it equal to 0 and solve for the solutions of the quadratic. So we're going to factor the following equations. This is example 2, and then we're going to solve using the zero product property. So we have x squared plus 7x plus 12 equals 0. I have to find two numbers that multiply to give me 12 and add to give you 7. So we could do 2 and 6, 3 and 4, and then we don't really have to go any further than that. Our factored form will look like x plus 3 and x plus 4 equals 0. We keep the equal 0. It's a equation. Now, using the zero product property, that allows us to take the first factor, which is x plus 3, set that equal to 0, solve for x equals negative 3. And then we take the second factor, x plus 4, we set that equal to 0, solve for x equals negative 4 over here. All right, we're going to take a look at x squared minus 25 equals 0. And if we want to factor this, hopefully you remember something from our factoring unit. This happens to be a special factoring case that we call the difference of squares. So the first term is a perfect square, the last term is a perfect square, and they're separated by a negative sign. So when we write this in factored form, we'll have the square root of x squared, which is x, the square root of 25, which is 5, and we'll have one positive factor and one negative factor. We solve using the zero product property, and we'll take the positive factor, x plus 5, set that equal to 0. Simplify that, x equals negative 5. And we'll take the second factor, x minus 5 is equal to 0. Simplify that, x is going to equal positive 5. Good, let's move on from here. So we have another quadratic to factor. And what do you see here? Hopefully, see, one thing that we should always look for is a common factor. So we can common factor. And we can remove or essentially divide out, right? You can divide out a 3. Let's common factor it first so you can see how this goes. X squared minus 3x. Oh, actually, sorry. Common factor this. We can take a 3 and an x from each term. So I'll have x minus 3 left over. So our factored form is 3x times x minus 3. And then we have the factors 3x and x minus 3. Using the zero product property, we can take the 3x factor, set that equal to 0. And when we solve this, we get x equals 0. 0 divided by 3 would be 0. And then we'll take the second factor, which is the x minus 3, set that equal to 0, and simplify here, x would equal positive 3. For D, we have another simple trinomial. We have to find a number that multiplies to give us negative 8 and adds to give negative 2. So I can do negative 2, positive 4. I can do positive 2, negative 4. And I think I've found them already. Here are my factors. So writing this quadratic in factored form, we'll have x plus 2 times x minus 4 equals 0. And the product property here, we take the first factor, x plus 2, set that equal to 0, solve for x, and we'll get x equals negative 2. And we'll take the second factor, x minus 4, set that equal to 0. And simplifying for x, we get x equals 4. All right, so now we have a quadratic that looks a little bit different. We have a coefficient in front of the x squared. So this is a more complex trinomial to factor. So we use, remember, that AC method. So we take a, which is the coefficient of the x squared term, and we multiply it by c, which is the constant. And here we'll get 6. So now we have to think of the factors of 6 that add to give me 7. So we have 1 and 6. Now remember, with the complex trinomial, we split this middle term, and then we do some grouping. So we'll have 2x squared. I'm splitting 7x into positive 1x. I'll write the 1. Plus 6x plus 3 equals 0. Then I'll go ahead and do my grouping. That's where we take the first and the second set, and we common factor each separate factor. So here I can take out an x in the first, and I'll be left with 2x plus 1. And in the second, I can take out a factor of positive 3, and I'll be left with 2x plus 1 equals 0. So since I have a common bracket for each of these terms, I'm going to factor that out. 2x plus 1, and I'll be left with x plus 3 equals 0. So we have our two factors, and now we're going to use our zero product property, and we'll set each of those factors equal to 0. So 2x plus 1 equals 0. 2x equals -1, and x equals -1 over 2. So that's one solution. And then we have x plus 3 as our second factor. Set that equal to 0. Simplifying here, x equals -3. So again, what do these solutions represent? They are the x-intercepts of the parabola, if you were to look at it on the graph. So find the quadratic function. Let's reverse here. Find the quadratic function that matches the graphs below. Assume a is equal to 1 in all of the examples. So what we're looking at here is we're trying to identify, so I'll zoom in here, the x-intercepts. So here is one and here is the other. So it looks like the first one here is 1, 2, 3, -3, and the other is -5. So x is -5, x is also -3. Those are the two intercepts. Now remember, when we factor and we pull those out, we set them equal to 0. It's always the opposite signs. So don't forget to change your signs now that we're working backwards. So if we put it into factored form, that -5 becomes a +5, and that -3 becomes a +3, equals 0. And then we have a binomial times a binomial, and we can expand using FOIL. So first, outer, inner, last, we end up with x squared plus 3x plus 5x plus 15 equals 0. We can collect these two middle terms, and our final function is x squared plus 8x plus 15. And that is our function in standard form. Let's take a look at a couple of other examples. Going to the next page. Let's zoom in here again. And here are our x-intercepts. And we look like this one is 5, and over here this one is 4. So my x-intercepts, we have x equals 5, and we have x equals 4. So if I put those back into factored form, then remember to change the signs. I'll have x minus 5 and x minus 4. Then we'll use FOIL and we'll expand this to get our function in standard form. So x times x is x squared. X times -4 is -4x. -5 times x is -5x. And then -5 times -4 is +20. All right, let's collect our like terms in the middle. And our final expanded form, yes, is x squared minus 9x plus 20. And we put that into an equation. In our next example, here we have one x-intercept. Here we have another x-intercept. Keep a close eye on the scale of the graph here. It looks like every box 2, 4, 6, 8, 10 is worth 2. So the first x-intercept over here is 2. And then over here be -2, 4, 6. So this one's -6. We'll go list our x-intercepts. We have x equals -6, and we have x equals 2. Put them into factored form. set them equal to 0. So we have x plus 6 and x minus 2. We'll use FOIL to expand, and I'll have x squared minus 2x plus 6x minus 12. Collect our middle terms. X squared plus 4x minus 12. And last one, here we go. We look like we only have one x-intercept, and it is 5. So if we have x-intercept, x equals 5, then we have a perfect square trinomial. So if a graph has one intercept, then you're looking to create a perfect square trinomial. So what that means is in factored form, we have two factors that are equal to x minus 5 and x minus 5. And of course, that's where we get our perfect square trinomial. X times x is x squared minus 5x minus 5x plus 25. And I collect the middle terms, and y equals x squared minus 10x plus 25. And we can see that that is our perfect square trinomial. So go ahead and try some of the examples on your worksheet, and I'll see you in the next lesson. Bye-bye.